Welcome to the Explainer. Okay, I am absolutely thrilled to be diving into this with you today because we're tackling what is easily one of the most exciting and critical frontiers in AI right now. Our goal today is clear. We are going to demystify exactly how to build a persistent, compounding brain for your AI agents. We're going to explore a really groundbreaking approach that fundamentally transforms how models understand and interact with your specific, unique data.
Okay, let's dive into this. Have you ever wondered why you can ask an incredibly smart, state-of-the-art AI agent a simple question about your business? Like, hey, what's our refund window? And it instantly, confidently replies 30 days when your policy clearly states 14 days? It sounds authoritative, right? But it's completely wrong. The truth is, it never actually opened your policy. It just guessed based on its generalized training data. To fix this, we need to completely change how our agents access knowledge.
To do that, we need a roadmap. So here's our plan for today. 1. The AI knowledge problem. 2. Enter open knowledge format. 3. How the format works. 4. The perfect hybrid stack. And finally, 5. Building your agent's brain. We're going to systematically break down this solution step by step.
Section 1. The AI knowledge problem and the limits of RAG and fragmented data.
You see, the real issue isn't that organizations don't have the knowledge their agents need. It's that this enterprise knowledge is highly fragmented across dashboards, wikis, support tickets, databases, and, let's be honest, trapped right in the heads of your most experienced employees. And this brilliantly illustrates the two totally different ways we try to solve this problem. On the left, we have standard RAG, or Retrieval-Augmented Generation. For the last few years, this has been the go-to fix, relying on probabilistic vector search where your data is essentially shredded into chunks. On the right, we have Google's OKF, the open knowledge format. OKF takes the exact opposite bet. It's deterministic, it relies on curated context crafted by actual humans, and it uses incredibly simple markdown files instead of massive vector databases.
So, why does RAG struggle so much with exact facts? Let's go back to that 14-day refund window example. RAG's critical flaw is right there in its ingestion pipeline. Imagine taking a clean, highly structured document, like a step-by-step procedure or a contract, and literally chopping it down the middle into disconnected chunks. The agent then yanks 3 fragments out of the database that look mathematically similar, but they've completely lost the original order that gave them meaning. The model is forced to guess the gaps between these disconnected pieces, and boom, that is exactly how a confident, dangerous hallucination is born.
Section 2. Enter open knowledge format. Google's vendor-neutral standard. Now, the beauty here is that we aren't introducing some massive, complex new software platform. OKF is just a delightfully simple standard, and it builds heavily on this fantastic concept championed by AI researcher Andrej Karpathy, known as the LLM-Wiki. Think about traditional RAG for a second. Every time you open a new chat session, that agent starts from absolute zero. It has to hunt for those fragments all over again. But an LLM-Wiki is entirely different. It's a persistent, compounding artifact. Think of it this way. The agent acts as the programmer, and the wiki is its codebase. As it reads more sources, it continuously updates and refines a structured web of knowledge.
Yeah, what's really interesting about this slide is the absolute minimalism of an OKF bundle. It isn't locked behind some expensive, proprietary API. It is literally just Markdown, readable in any basic text editor. It's just files hosted in any standard Git repository. And it's just YAML frontmatter, a tiny block of metadata at the very top of the file. Because it's so incredibly basic, literally any AI agent can natively read these files without requiring custom integrations or clunky software development kits.
Section 3. How the format works. We're peeling back the code here. Let's look at the actual mechanics of how we construct this format to organize an agent's knowledge base.
If you remember absolutely nothing else about the technical spec today, remember this. According to engineer Sasha Becker, there is a single hard requirement for an OKF file to be conformant. Every single document must carry a non-empty type field in its YAML frontmatter. That's it. It's that simple. But that one tiny tag ensures the agent instantly knows exactly what it's looking at, whether it's reading a database table, a business metric, a playbook, or an API schema.
Once your files are structured, the agent steps in and takes over the heavy lifting, using Karpathy's 3-step operational flow. Step 1 is ingest, where the LLM reads new raw sources and writes summaries directly into the wiki. Step 2 is query, where the agent searches its own structured files to synthesize answers. And step 3, which I absolutely love, is lint. Periodically, the LLM runs health checks on the entire wiki to flag any contradictions or update missing links. Honestly, the LLM handles all that tedious, soul-crushing bookkeeping that usually makes humans abandon traditional wikis altogether.
As your knowledge base inevitably grows, OKF relies on this brilliant concept called progressive disclosure, using index files. Instead of an agent doing a brute force vector search across thousands of documents, it reads a root index.md file first. This index gives a broad overview, mapping out subfolders for specific topics. The agent then systematically drills down into exactly the folders it needs, reading the YAML metadata first. This methodical approach is a huge deal because it saves massive token costs and drastically speeds up the time it takes to retrieve exact facts.
Section 4. The perfect hybrid stack. OKF and RAG working together.
The real secret to the ultimate AI architecture is realizing that this isn't a battle of OKF versus RAG. No, the stack that actually wins in production is OKF plus RAG. Think of this hybrid setup a bit like human anatomy. OKF serves as the curated, highly structured spine for the 80% of answers that are high stakes and canonical. The things your business literally can't afford to get wrong, like pricing tiers or compliance rules. RAG, on the other hand, acts as the sprawling reach for the messy, unbounded 20%, like massive archives of old support tickets or fuzzy searches you could never manually curate. You just drop a thin router in front of your agent, and it intelligently directs queries to the right system based on the stakes of the question.
Section 5. Building your agent's brain. Real-world application. Let's move to and see how this builds out in reality, grounding this with concrete examples from individual use cases right up to massive enterprise integration.
First, on an individual scale, take Dr. Marie Haynes. She's a leading SEO and AI expert who built her own personal OKF brain for her agent, Anti-Gravity. She uses OKF to store her unique SEO playbooks. By automating the ingestion of daily Google documentation updates right into her OKF structure, she creates these complex procedural checkpoints for her agent to follow. The results are just astounding. What used to be a tedious 2-day manual analysis task has been reduced to mere hours. That is the sheer power of documenting your wisdom in a format an agent can seamlessly execute.
So, the crucial point is really seen when we scale this to the enterprise level. Notice the stark difference here between a raw AWS SQL schema on the left and an enriched OKF concept on the right. If you just give an agent a raw database schema, it sees a table called revenue and a column called customer ID. Sure, that's useful, but it's dangerous. An enriched OKF concept wraps that raw data in a governed knowledge layer. Now the agent actually knows the business purpose is recognized revenue. It knows the finance team owns it, and most crucially, it knows it must mask personally identifiable information before sharing it. That context is exactly what prevents your agents from making catastrophic data mistakes. I really want to highlight this brilliant point from cloud architect Amit Kayal. He notes that enterprises absolutely do not need another portal or wiki where knowledge goes to die. Instead, he says, models give reasoning, tools give execution, knowledge gives enterprise judgment. That hits the nail right on the head. True enterprise differentiation isn't going to come from bolting 20 new software tools onto your agent. It comes from building a unique, governed knowledge layer that teaches your agent exactly how your specific business operates. Which leaves us with this final provocative question. As you step back and look at your own AI architecture, ask yourself, are you truly building a compounding brain for your agents, or are you just handing them a bunch of shiny new tools and hoping they figure it out? The open knowledge format offers a beautifully simple, scalable path to governed AI intelligence. I really hope this explainer leaves you eager to rethink how you structure your own knowledge base. Thanks for joining me today, and keep building.